let's do it this way. We will, go through the first question. That's something which I think we all know, but let that be a starter. We'll do the first two questions. These are multiple choice questions. Or let's do the first three questions, multiple choice questions. And then we'll probably hear you people as to which one you want me to solve. The slope of a displacement time graph. So what does the slope of a displacement time graph give us, folks? The slope of one displacement time graph. And two, the distance time graph. Yes, all of you. Are you familiar with what is going on? The slope of a displacement time graph gives us what? So we have a displacement time graph. And let's say this is the graph. Then what does the slope give us, folks? What does the slope give us? Slope is the y minus x, right? Let's not get into the complications of what a slope is. You must have known this already. What is the displacement time graph slope? So if you are not sure, if you are keeping quiet, I don't know why, then the displacement time graph gives us velocity. And the distance time graph slope gives us speed. Okay, so velocity comma speed is the answer, and where the answer choice C is the right one. Let's solve number 2. The average velocity of a ball thrown upward and caught again. So we are talking about velocity. So if we are talking about velocity, should we consider displacement or distance? Logical. Displacement. Now, displacement is the shortest distance. We know that displacement is the shortest distance between the initial and final position. If I throw a ball and it comes back to me, what is the displacement of the ball?
0.
0. So velocity is 0. That's it. So the average velocity of a ball thrown upward and caught again is 0. 2D is the answer. Why, sir? Why is it 0? Because the displacement is 0. We are talking about velocity. We are not talking about speed. We are talking about velocity. What is velocity? It's displacement by time. If you throw a ball and it comes back to you, the displacement is 0. The shortest distance between the initial and final position is what? It has come back to exactly where it started from. No movement in terms of displacement. It's been 0, right? Displacement is 0. So displacement by 0. Displacement is 0. 0 by something will give us 0. Question number 3. The position time equation is what? So there are 3 equations in motion that we know in all. V is equal to u plus at. S is equal to ut plus half at square, and v square minus u square is equal to 2as. And the question is about the position time. Look now, it's just about elimination or the selection. This one, yes, it talks about time, but it doesn't talk about displacement anywhere. So this is ruled out. This talks about displacement, but there is no time in this equation. This is the only one where we have displacement, which is position, and time as well. So the only equation which has both position and time is this. So answer choice B. Folks, before we go on to question number 4 and the questions involving solutions and the, a little of subjectivity, not subjectivity, but there is no subjectivity in physics, but those which are beyond the multiple choice questions, are we all absolutely fine, folks? Are we absolutely fine? Any confusion with 1, 2, and 3? Yes, online folks. I'm not asking the physical folks. I can ask the physical students right away. Hey, ho gaya? Yes, they say. I'm asking you people. Are you good? Are you good?
Yes, sir.
Yes, sir. Yes, sir.
All right, chalo, good. Let's move on to questions. So we want to keep a check on the time, folks. We don't want to solve every question and end up solving only up until question number 10 or 12. No, we don't want that. We want to go through this complete worksheet today, 20 questions, and that obviously means that we'll have to skip some questions which you don't need to solve. Let me know from question 4 to 5. Let's do it this way. We'll go in blocks. So I've already solved 1, 2, 3. Look at 4 and 5 and tell me if you have doubts in either or both or none. Question number 4 and 5.
क्या करना जी आप वो मेरे को नहीं आ रहा था क्या कर रहे थे
Please go on mute, folks. Please go on mute if you're not speaking to me. And folks, just one caution. Don't turn the together mode on and all. Please be cautious. Just let us focus on this class. We are here a day before the exam so that we make the most out of this session, right? Let's not get into adventures of setting some together mode and people keep struggling. Aadha ghanta nahi, 5 minutes with barbad ho jata. Let's not do that, okay? So let's be careful. Let's not click on things which you don't need to. Question number 4. Shall I skip this or do this, folks? Let us not waste time waiting, to know whether we need to solve this or not. Question number 4, is everyone good? Or is anyone having problems with question number 4?
So can you solve it?
Question number 4. Yeah, please tell me quickly, folks. Whichever you want me to solve, let us not waste any time. Okay, so I will very quickly draw this graph. Let me do it quickly. So ऐसा कुछ है. And then there is something like this. And then there is something like this. Let me extend this a little. Hold on, folks. I will move from the board. I know I'm blocking your view, but let me complete this first. And then we have. All right. So I think we solved this question yesterday, right? In our class, a regular class, all of you. My batch time is given here in seconds. And this is velocity given in meters per second. This is the graph. Now, these are points. This is time 2. This is 5 and this is 6. This is B and this is C. Wonderful. Now, what is the distance traveled by? Sorry? Velocity. This is 15. Okay. This is 15. And it's going this way. All right. So now let us solve this quickly, folks. 4. This is question number 4. And we are talking about A. What is the distance traveled by the SUV in the first 2 seconds? We already have the graph. You can actually use the equation of motion to solve, but don't do that. You'll take more time. If you have the graph, now you don't have to write this, but in velocity time graph, what is distance, folks? What is distance? What is distance? Velocity, in this case, they are using velocity, but it should be speed time if they are talking about distance, but that's fine. In velocity time graph, the distance covered is what? Distance covered, is it not the area of the graph under this line that it forms with the x-axis? So in the first 2 seconds, this is obviously a perpendicular. So here the distance will be what? The distance here will be, folks, half into base. Base is 2 and height is 15. So 15 meters, mind you, it's in meters per second. So you must get this units right. This is the first, in the first 2 seconds, the body covers 15 meters. It's traveling pretty good. B, what is the braking force at the end of 5 seconds? What is the braking force? What is the braking? What is force, folks? What is force? We know force is equal to mass into acceleration. Is everyone good with this? Hey, they have given the value of m. Here, m is equal to, it's given in the question, folks. Read the data or information before, just above the figure. The mass of the SUV is 1000 kg, right? So we are good with the mass. So all we need to do is the acceleration. And which portion is this graph referring to, folks? It is, what is the braking force at the end? So look here, look here. At the end of 5 seconds, do you see that the velocity of this body is decreasing until it reaches 0.6? At 0.6, at not 0.6, but this point, I'm referring to this point. At this point, you all agree that velocity is zero. It's on the x-axis. So on the x-axis, the y-coordinate is zero, right? So v is equal to zero. And what is the, so this is the final velocity of the body. What is the initial velocity? When you are considering only this segment of the motion, then you all agree that u is equal to 15 meters per second. And what is the time in which this drama has happened? 1 second.
1
So
second.
can I not calculate acceleration as v minus u by t? V is 0 minus 15 by 1. So this is minus 15 meter per second square. Sir, why am I getting this minus sign? Because it is negative acceleration. The brakes are being applied. It is
Retardation.
not increasing. It's retardation. In short, we call it retardation. It's negative acceleration. So therefore, the force that is applied, therefore, the force is mass into acceleration. Let this minus sign remain. It will be minus 15,000 newtons. There is a significance of this minus sign, folks. It is force is a vector quantity. Plus 10,000 newton is different from minus 10,000 newton. Here the force applied is minus 15,000 newton, folks. Minus 15,000. Let it be minus here. Let it be minus. You can write one line summarizing things that because this is negative acceleration or retardation, force is coming out to be a negative quantity. Even if you don't write, I think it should be fine. But I hope you have understood this completely, all of you. Question number 4, are we good? Let us do a time check. We have done 12 minutes, 13 minutes in which we have, let's see, I don't think we can figure out our rate yet, but we'll probably speed things up in case we are going slower. If our required rate is getting past 20 runs per hour, then I think we'll have to take chances and skip questions. But for now, are you people crystal clear as never before with question number 4? Absolutely clear. If you are just following this session, folks, I guarantee you that you will not get anything wrong, at least in physics. I don't guarantee you bio and chemistry because not doing those. But if you are just following up, bringing all your attention to this class for the next 1 hour, I guarantee you, folks, that at least in the physics numericals, you will get nothing wrong. That's my guarantee. So just let me know for now if you are absolutely clear with this.
Yes, sir.
Done copying, then I will erase. Yes, folks, I'll erase. All good?
Yes, sir.
Look at question number 5, folks. Let us see if you are good with 5. Question kya hai? Number 5. A train starting from a railway station and moving with uniform acceleration attained a speed of 90 kilometers in 5 minutes. I'll very quickly do this. I'm not going to solve this completely. I will just tell you what all you must do. Many of you, I'm sure, can do this. Starting from railway station, read in between the words, not in between the lines. Read in between the words here, folks. Physics questions will not give you everything on the platter. From the language, the English of the question, you'll have to infer things. So a train starting from a railway station, does that not mean that initial velocity is 0?
Q equal to 0.
Absolutely. Good, Tejashwini. So a train starting from a railway station, moving with uniform acceleration, we don't know how much, it attains a speed. It attains a speed of 90 kilometer per hour. So for the section of the motion that we are interested in, u is 0 and v is 90 kilometer per hour. We don't know whether we need this in meters per second or not. But the good news is that it takes us 2 seconds to convert. So just keep this ready. 90 into 5 by 18
25 meter per
meters
second.
per second.
25 meter per
So
second.
18 into 5. So it will be 25 meters per second. Mind you, this is meters per second because this is velocity. All right. Now find the acceleration. We know acceleration is equal to v minus u by t. So v is 25 minus
We
0.
have to convert the
60 by
time, sir.
600 seconds.
Yeah, so I didn't write here. Look at this, time is given in minutes. It's 5 minutes, is it? So convert this to seconds, because everything else is in meters per second and things like that. Even
300
because
seconds.
this is in minutes and we have to convert this to seconds, it was important that we converted kilometer per hour to meters per second. So this comes to 300. So this will be 300. 25 by 300, folks, is 112. 1 by 12 seconds. Sorry, meter per second square. Meter per second square. We could have kept it to kilo. This looks a little weird, but that's fine. In kilometer per hour, it will give you some other value, but this should be fine. Okay, if you convert this to, if you multiply this by
0.08.
1000, no, why 0.08? You have to, yeah, okay, yeah. So it will be kilometer per hour square. So even this one, kilometer per meter per second square is the acceleration, right? If you convert this to, you don't have to. This is fine, yeah. This is fine. Yes, this is fine. Okay, so are we good with number 5 as well? So we can solve number 6. If you're copying, just you can copy both together. Question number 6: a trolley while going down an inclined plane has an acceleration of, look, acceleration is equal to 2 centimeter per second square. Okay, what will be its velocity after 2 seconds? What I suggest, folks, what I suggest is convert this to meters. You don't need it here, but it's a good practice. If we do it sometimes and we don't do it sometimes, we are confused as to when to do it and when not to do it. So it's better to do it, either convert it to kilometer unit or meter unit. Here it will be very weird to convert this to kilometer. Doesn't make any sense. Convert this to meter. So don't you think that this will be 2 by 100 meter per second square? Yes, all of you agree? And then
Yes, sir.
what else? A trolley while going down an inclined plane has what will be its velocity after 2 seconds of the start? 2 seconds of the start means u is equal to 0. It started from somewhere. So it started rolling down. So it started rolling down an inclined plane. So it started from rest 0 and it secured a velocity of, we don't know. That's what we have got to find out. And all of this drama happened in 2 seconds. Yes. Can it get easier? So we have got, we know
V
v is
equal to U
equal to
plus 80.
u plus 80. Apply this equation of motion and you get it. So it's 0 plus 2
Sir,
by
can you
100.
explain this again?
Where did you miss it? This is acceleration given in centimeter per second square. So I converted it to meter. So it is 2 by 100 meter per second square. I hope this part is fine. Yes, this part
Yes,
is
sir.
fine. From centimeter I converted. Now it has started from rest. It has started from, where did it start? There is no information given as to what the initial velocity is. So when it says from start, we have to assume that it is starting from rest. This is how the convention is. So the initial velocity is 0. Final velocity is what we have got to find out. How much? Hey, it's, if you look at it practically,
But sir,
there is an
final
inclined
velocity
plane.
is already given.
How much is velocity is given?
Sir, it said that what will be its velocity after 2 seconds of the start. Means final
That's
means
what we have to find out. No, what will be its velocity?
initial velocity will be 2 seconds, no sir.
No, what will be its velocity? 2 seconds. What will be its velocity after 2 seconds of the start? How can initial velocity be 2? What is its velocity after 2 seconds from the start? After 2 seconds. So at the start it was 0. After 2 seconds, what is its velocity? Hey, it's something like this. This trolley is sliding down. It has a velocity. It started from rest and it is now sliding down. It is sliding down. So after 2 seconds, it has reached here. Obviously, it is accelerating, right? It is accelerating. It is accelerating, and that's given. So acceleration means change in velocity. So at this point, what is its velocity is what we have got to find out. That's what we are finding out. And look, it will be positive. It will be positive. It's not negative. It's going in this direction. So 2 by 100 into time. Time was how much, folks? 2 seconds. So is it not 4 by 100? Or 0.04 meter per second square? or if you want to keep it in centimeter, it will be 4 centimeter per second square, because the initial thing, sorry, this is velocity, right? So it will not be second square, folks. It will be second, because the acceleration was given in centimeter. I am keeping the velocity also in centimeters. So this will also be square, not be square. Copy this, folks. Copy this quickly. Question number 6 done. We will not be solving all questions. Hey, folks, we will not be able to do it otherwise. Let us now do one thing. We'll solve alternate questions. We'll solve alternate questions. This was what, number 5. So we'll solve 7, 9, 11, 13 and all. After we have completed all, we will come to the even questions. Make sense? That way we will at least span the entire paper. Otherwise, we would be struggling at around, floundering, call it, or whatever, at question number 10 or 11, and will not be able to solve. So from here, I am solving, oh, I've already solved 6. So let me solve 8, 10, 12, 14, 16, 18, and 20. And then we will come across, I will come to the odd numbered questions as well. Copy this, folks. I'm taking a 30-second break.
Sir, but why did we
Yes, so
convert
whoever was,
it into meter per second square?
I think I told you, Tejashwini, that the units, the SI unit is meter per second square, meter. And the other unit that we are accustomed to is kilometer an hour, meter second, kilometer an hour. So to be consistent, don't use any other unit during the solution. After you have found everything, you can convert this to centimeter again, but don't try out with any other unit, any unit other than kilometer hour or meter and second. That's the reason I converted this to meters per second square. Makes sense?
Yes, sir.
All right. So now next one, question number 8. Read the question, folks. Read the question. Get the question right before we solve. Let's read the question. What is question number 8? A man pushes a box. Question number 8. A man pushes a box of mass 50 kg. Don't read anymore. Just note whatever is given. This is the golden trick, I would say. Just keep noting things which you come across in the question. Otherwise, if you read the entire question, you will again go back to square one. You would waste a lot of time. A man pushes a box 40 kg. And what is the force with which he is pushing, folks? 100 newtons. This comes under the force and laws of motion. What will be the acceleration of the box due to the force? Hey, such an easy question. A is equal to
F
what?
equal to
How
M
should we
into
go
A.
ahead, folks?
S
So
equal to
F is equal to M into A. That implies A is equal to F by
F
M.
by M
So F is 100 and M is
by
50. And the unit, if this is in kg and this is in Newton, folks, get it right. A will be 2
20.
meter.
2 meter per second square.
20 कहाँ से आ गया? 2 meter per second square, no? Have I missed something? How is it 20? No, I think this is right.
No, sir, 2 is only
What
correct.
would be the acceleration? Yeah. What would be the acceleration? Now, case 2. We are talking about the second part. The second part of the question. Second part. What would be the acceleration if the mass were doubled? Look, you can see here, right from here, that if the mass were doubled, the acceleration would be halved, right?
M
It's
into
inversely
2,
proportional.
sir. Mass
Next.
into 2. Mass into 2.
Yes, so in this case, mass is still 50 kg. No, mass is doubled, they say, right? If the
Yes, sir.
mass is doubled,
100.
so
100
mass
kg.
is doubled.
Into 2. 100.
100 kg. 100, no, what into 2? That's it. That's what we have done. That's right, 50 into 2. And the force applied is the same. 100 Newton. 100 Newton. Hey, common sense. If you are applying force on a heavier thing, the acceleration will come down, right? So if the mass is increased and you are applying the same force, the acceleration will reduce. We know A is equal to F by M. So in this case, it comes to 100 by 100 is equal to 1 meter per second square. All right, so let's save time and we'll solve number 10 as well over here. You can copy both of these things. Number 10, what can you talk about the motion depicted? Wonderful questions here, folks. I want you people to completely get each one of these graphs right. Okay, just listen. Don't be in a hurry to copy. I will give you time to copy. Just listen to this one. The first one that we have is, this is what is a velocity time graph. Velocity time graph, and this graph is showing a line which is parallel to the x-axis. It can't get easier than this. What does this graph represent, folks?
Zero acceleration,
Uniform
constant
motion, right?
velocity.
This is uniform motion.
Uniform.
Uniform motion or velocity when a body covers equal distance in equal intervals of time. Why? Because the velocity is constant. So this is uniform motion, constant velocity. It's already written there. Number 2, this is once again a velocity time graph, and you have something like this. Hey, the velocity is increasing. Now just ask yourself one question. When there is a ask yourself one question. Just tell me yes or no. Is the velocity changing in this graph? In the first graph, is the
No, sir.
velocity changing? Just tell
No.
me yes or no.
No.
No, the velocity is not changing, and we know that acceleration is change in velocity by time. So don't you see that the numerator will be zero here? There is no change in velocity. Change in velocity is zero. So this has zero acceleration. Yes, all of you. In this case, just tell me yes or no. Is the velocity changing?
Yes, sir.
Yes, sir.
So this is accelerated motion. Simple as that. There is acceleration because there is velocity change. If there is, yes.
Acceleration motion, sir. Uniform or non-uniform?
No, it cannot be uniform. No, the body is not covering equal distance in equal interval of time. This is non-uniform motion.
Non-uniform acceleration.
Non-uniform motion, or this is accelerated motion. No, if accelerate, will come to that graph. If the uniform is acceleration is uniform, yet it's actually uniformly accelerated. This is uniformly accelerated, but we are focusing on the VT graph. We say it's a non-uniform motion. The body is not covering equal distance in equal intervals of time. But because it's a straight line graph, the acceleration will be uniform. Let us not do too many things in the same graph. We'll come to that a little later. But are you good with these two cases, folks? This is uniform motion. This is non-uniform motion. This is acceleration. Quickly, folks, we don't want to spend a lot of time on one question, but this is important. The next one is again a velocity time graph. And this time it is something like this. Now, what is the difference between here and here? Look, in this case, hold on. I'll just tell you one thing and then ask
Uniform
questions and you can share your
retardation.
thoughts. In this case, yeah, so yes, it will be retardation. In this case, the velocity is changing. Yes, sir, it is changing. Is the velocity increasing? Yes, sir, it is increasing because it is going up. So it is
Sir, is
increasing
it
and changing.
uniform
Here
retardation?
also it is changing, but it is decreasing. It is retardation, right? It's decreasing at any point. If you took look at the velocity, at this point it is here. At this time, if you look at the velocity, it is here. So the velocity is decreasing, right? So it is again non-uniform, non-uniform, and this is retardation. Wonderful, great. Yes, you're getting it. Good. So this is 3. Hey, we don't have a lot of board space. I think you'll not miss. I will draw this here, okay? Maybe 4 and 5 I'll draw here, or maybe I'll draw 4 here and 5 there. Sorry about this. 4.
Sir, excuse me, sir.
Sir, in the third one, why can't we call it
Yes.
as uniform retardation, sir?
Of in
Because it
uniform
is,
retardation. This is
sir,
non-uniform. It is retarded motion and it is non-uniform motion. Yes, it is uniformly retarded as well. That's also correct. Yes. Yes. What was the next thing? It's not that. It's not that this and uniformly retarded are mutually exclusive. It is non-uniform. It is retarded and it's uniformly retarded. All three things are right. So it's good to write. If they just ask you to just write about the behavior of this graph and it's not a multiple choice question, you can actually write all. Yes. Somebody else had a question.
Sir, this is also a negative acceleration, sir.
This is,
Sir, can
we'll
we,
see.
sir, can
We'll
we
see.
show a body moving to rest in a velocity time graph?
Can we show a body moving? Yes, everything is along this. The graph of the motion is here. Velocity is 0 as the time increases. So the body is at rest. Getting it, Subrat? Subrat's question, nice question. Can we saw a body at rest in a velocity time graph? So the motion is along this line. As time increases, the velocity is 0. So this is the velocity time graph which shows a body at rest. Convinced, Subrat?
Yes, sir.
Now, let us look at this. This is interesting, folks. Just try to understand. Don't write anything. You will miss it otherwise. Just get this right, folks. Get this right. This is V and this is T. See, in this case, what is happening? What is happening from here to here? Let me divide this graph into two parts. AO, or well, this is O. So let me call this B and C. In the part AB, just tell me only what I'm asking you. Is the velocity negative or positive?
Sir, it's
Sir, negative, sir.
Negative.
No, it's positive. Yeah. How can it be negative? It's
Sir,
positive.
from
No, it's
A to B
above
it
the
will be
x-axis.
positive.
sir, it's
From A to B it
decreasing.
will be
Yeah, from
positive.
A to B, it is positive. And it is decreasing. You all agree?
Yes,
Yes,
sir.
sir. Sir, why positive?
It is decreasing. Sorry, say again.
Sir, from A to B it's positive and from B to C it's negative.
Yes. So B to C. Now let's look at this. B to C, it is negative, but it is increasing. Don't you see that? Hey, it is -1. If you plot these points on the y-axis, you will see that the negative value is increasing. Here the positive value is decreasing, and here the negative value is increasing. Here again, I repeat, look at these 2 points. At time 1, at 1 second, at 2 seconds, at 1 second and 2 seconds, at 1 second, this was the velocity, let's say 10. And at time 2 seconds, this was the velocity, that's 5. So it's positive. Both are positive, but don't you see that the velocity is decreasing in the AB part? Making sense, all of you? Making sense? So in the AB part, the velocity is positive but decreasing. In the BC part, the velocity is negative but increasing. Is that clear, folks? If you are clear with this, then I will tell you what it means.
Clear, sir.
Yes, sir. Clear.
When I throw, now just look at this. I'm hiding the graph. I'm just telling you what I am trying to explain. If I throw a ball, just consider the first part of its motion, the ball going to the maximum height, the ball starting from rest and going to maximum height. Making sense, all of you? The ball starting from rest and going to maximum height. So during this time, if we consider this direction as positive and this direction as negative, niche se upar is positive, upar se niche is negative, then don't you appreciate that the velocity of the ball is gradually decreasing? Yes, all of you. The velocity of the ball is gradually decreasing. You threw with some force, so at that time the velocity was maximum, but the velocity is dying down, dying down, dying down until it reaches the top. So at that point, even though this velocity has all been positive because it is going up, its velocity has been increasing. So this part of the motion AB is representing the upward journey of the ball. Yes, after it has reached the maximum height, at that point its velocity becomes 0. This point B represents that time when its velocity is 0. After that, look what happens. The velocity has started increasing. It's going in the negative direction, but it's increasing. It's going in the negative direction, but it's increasing. So this is about a motion of a ball which is thrown upward.
Negatively
Making
increasing.
sense, all of you? Yes, negatively increasing because it's following this direction. Velocity is a vector quantity, folks. Speed time graph of this motion will be different, but velocity indicates direction as well. So here, even though it is increasing, even though it is decreasing, it is actually going up. Here, even though it is negative, it is increasing, and that's what it represents. The ball going upward, AB, the ball falling down, BC.
Sir,
Velocity
AB is
decreasing,
still positive.
velocity increasing. Yes, that's what
Sir,
I told you, right? The ball is, even though it is slowing down, hey, listen. Even though the ball is going up, is its velocity not coming down? Is it not decreasing? It is decreasing. That's why after a certain point, its velocity becomes zero and it then starts falling down. So I'm not explaining the other graphs, folks. It take a lot of time. If you have any specific interest, you can tell me, I'll explain. Otherwise, we'll end up spending all the time on graphs. Are you good with question number 10, all of you? Yes, somebody had a question. Quick one, please.
sir, BC is increasing rate, sir. It's increasing and does not stop at one
BC increasing.
point. B
It
to
doesn't
C.
stop. It stopped here. That's what I told you. When I threw the ball, it went to a maximum height and it stopped. Momentarily, it stopped, right? That is when the velocity is zero. This point represents that scenario, that instance, when the ball reached the maximum height.
Sir, this is the 0 point rate, sir. B is 0 point and C is a decreasing point and A is positive.
No, what is a 0 point? What is a 0 point? There's nothing called a 0 point. This, what does the velocity? If something lies on the x-axis, its y coordinate is zero. So here, don't you see that the velocity is zero? The velocity is zero at this point. That's the scenario when the ball has reached the maximum height and it has stopped. Hey, I think we have explained all. You can go through this part of the video after the session. This session is anyway getting recorded. You will get it. I tell you, I've explained all. If somebody has missed it, it's because of some distraction, or maybe some prior thing missing. But I tell you, this has been explained thoroughly. Please go through the recording. Otherwise, we'll not be able to complete the worksheet. Full stop now. Time out on this particular question. Copy this quickly and we'll solve number 12. No more questions on this now. Those who are done copying, I will solve question number 12. Next is 12. Yes, folks, are we done copying? You can probably take screenshots as well today. I mean, other days I don't encourage screenshots, but probably because so that we can save time and solve more questions, take screenshots. You can refer to those after the class. Go through question number 12, folks. Question number 12 is the next one that we are solving. Question number 12. Let's do it. Question number 12. What is it? Say if two objects move in a circular path of radii in the ratio. So the radius of two motions is given. One is it's in the ratio 1:3. So if this is x, if this radius is x, this radius is how much? 3x. You all agree?
Yes,
Now, if
sir.
two objects move in a circle, this is question number 12, folks. Right? If two objects move in a circular path of radii and take the same time to complete, what is the ratio of their speeds? So in time t, this body, let's call it A and this is B. It is taking this much time to complete one circle. If two objects, it takes some complete the circle. So don't you think that in time t, the distance moved,
Take a distance
the
formula.
distance moved in this is equal to 2 pi into x, and this guy would have moved 2 pi into 3x.
Sir, it will
Easy,
be
right? So this is equal to 2 pi x and this is 6 pi x. Now let's look at the question. What is the ratio of their speed? Speed is what, folks? Speed is equal to distance by time. So what is the distance? 2 pi x by t. And in this case, it is 6 pi x by t. If you take the ratio, it will come to 1:3.
Sir, if you
Yes,
take
all of
even
you.
2 pi r by 2, distance formula 2 pi r by 2, pi r into x, still it will be 1:3, no sir.
Why do you have to rely on formulas, folks? The ratio of the, what is the ratio of the speed? Speed is what? Distance by time. So for circle A, distance by time is this much. For circle 2, distance by time is this much. If you now take the ratios of these two quantity, it is 2 pi x by t into t by 6 pi x. No, t gone, x pi gone. 2 by 6 is 1 by 3. Don't rely on formulas unless you cannot help it, folks. I always tell, don't rely on formulas
Sir, in
unless
the
you have
figure, why
thoroughly
did you
understood what the formula is doing.
Sir, in the figure, why did you
In,
take x and 3x sir, instead of taking 1 and 3?
because the ratio, hey, because it's the ratio, yeah. Ratio means what? Ratio is not a quantity, no. It is 1:3. It is 1:3. It means that it can be 1 and 3. It can be 2 and 6. It can be 3 and 9. It can be 100 and 300. So I have taken the quantity as x and 3x. This is how we do. No, if two friends have masses in the ratio 5:7, then what are the masses we take? We take 5x and 7x. No, we don't take 5 and 7.
Sir, I have a
All right,
doubt.
question number, 14. Yes.
Sir, I have a doubt. Sir,
Yes,
Sir,
tell
can
me.
you explain 13 to
circle
me?
and they
Go
said
ahead,
to
tell me.
find the, sir, they gave the circumference of the circle is 1:2 ratio. They told us to find the displacement. What should we do?
The displacement will be 0. No, what is the displacement? You're completing a circle. Your initial and final position is the same. So your displacement is 0. No matter how big a circle you move, you move a small circle or you move a large circle. End of the day, your displacement is 0. No. So if two
But
quantities have
one
zeros as their, it
the
doesn't matter.
displacement.
That's what I tell you. It doesn't matter how large. Hey, listen, you're not listening. Just listen to me. What will be the ratio of the displacement? It doesn't matter. The displacement is the same in both the cases. Let's look at this circle. You start from here and you start from here. If you have completed one circle and reached here, what is the displacement here, folks? 0. What is the displacement here? 0. It doesn't matter how small a circle or how large a circle you are covering. The displacement is 0. So there the ratio doesn't arise. It's the same. If it is 0, what is, I have 0 in my pocket. You have 0 in your pocket. And now they ask us to find out what is the ratio of the money they have. It's the same question, no? Is it not? Yes. So let's look at, and somebody asked me to solve number 13, folks. I will come. Let us not deviate from the rule. After we complete all the even numbered questions, I'll solve number 13. Okay. So we are solving question number 14 for now. A train traveling at a speed of 36 kilometer per. A train is traveling at a, so initial velocity is 36 kilometer per hour. This is where we are recording the journey from, recording the motion from. So what is the initial velocity? 36 kilometer per hour. We may need or we may not need, but it takes us 10 seconds to do the conversion. So keep the conversion ready. This is, you know, right? This is the conversion
10 meter
factor.
per second.
So this is how much, folks? It is 10 meters per second. Good. This is, brakes are applied so as to produce uniform acceleration of acceleration. It's already given that this acceleration is minus 0.5 meter per second square. That's why I was telling you, don't wait for this conversion. The fact that it takes us just 10 seconds to make the conversion, do it right away. We may need, we may not need, that's fine, but it takes us only 10 seconds. And look, here right away, we see that this is given in meter per second square. So if we had not converted this now, we would have had to convert now, right? So it's good to make the conversion. All right, let's do this quickly. How far will the train go before it is brought to rest? So velocity is equal to 0. Catch these keywords. Start. A boy starting from rest. Initial velocity 0. A girl finally coming to rest. Final velocity 0. So this body comes to rest, which means final velocity is 0. And we have got to now find S. Look, in this case, there is no reference to time at all. We know the three equations of motion. V is equal to U plus AT. S is equal to ut plus half at square, and
Third
v
equation.
square minus u square is equal to 2as. We are required to find S. The first equation will not give us S at all. The second equation can give us S, but we don't have T. So we cannot use this either. This is the formula to use. Yes, all of you. Now apply this formula. V square minus U square. What is V square? 0 square minus U square, 10 square is equal to 2 into minus 0.5 into S, right? S is what we have got to find. So that gets us what? Minus 100 is equal to minus, this becomes minus 1 S. Therefore, S is equal to 100 meters. Get this right. So train was traveling at this speed. It applied brakes. And from the time it applied brake, it still travels some distance before coming to rest, right? That distance is 100 meters. Question number 12, copy karo jaldi, folks. I think this is 14. Good. We are going good. 14 done. We'll solve 16, 18, 20, and then come to 13, and then we'll see if we can solve more questions. Making sense, class 9 students, all of you.
Yes, sir.
Good.
Sir, isn't 10 square as 100?
Yeah, so what else have I written? 10 square is 100, but have I not written 10 square as 100? What's the confusion? Hey, tell me, have I done something wrong, or have you followed something which is not in accordance with what I have done? Can be either one of the two cases, right? If I am wrong, I'll correct it. If you have not understood, I'll explain. Simple. So we're good with number 14. Number 16, I heard from you people. In fact, yesterday we were discussing this, and Tejashni, you're talking about this, right? We discussed that this is not in scope. They are not going to ask you graphical motion. So I don't say that if they're not asking us, we should not know. But really, this is not the time, right? We are having our exams tomorrow. So we'll not do something which is out of scope. We'll probably do it in some other class. It's a very important derivation. We must know how to derive it, but let's not do it now. Number 16, we'll skip. Number 18. A bullet is fired into a wall. Get this right, folks. Just take your physics hat off. As I always say, take your physics hat off. If you wear the physics hat and then read questions, sometimes you don't understand the question. That's why while reading the question, remove your physics hat, get the question right, then put the physics hat on and then solve the question. Number 18, let us see how it works, folks. Number 18, what does it say? It says that a bullet is fired into a wall with a velocity of 50 meters per second. If the bullet stops, so up until here, if the bullet stops, it is fired with a velocity of 50 meters per second, fired with velocity is equal to 50 meters per second, and it comes to rest because it is hit in a wall. Obviously it will stop somewhere, comes to rest. So from this much information, can we not conclude that u is equal to 50 meters per second and v is equal to 0? Absolutely clear, everyone?
Yes, sir.
Yes, all of you. If the bullet stops at a depth of 8 centimeter, what is this 8 centimeter doing here, folks? It is the distance that the bullet has traveled. Distance is equal to 8 centimeter. Straight away convert this to meters, 0.08 meters. Wonderful. Find this acceleration or retardation. Obviously, it's retardation, but we'll see what it is. It must come to minus value. We know before and we don't know what its value is. We'll find that out, but it must be negative. Yes, because it is slowing down. So again, here there is no time involved. So don't you think that we will apply the third equation of motion, folks? V square minus u square is equal to 2as. Absolutely clear why we are not using other equations of motion. Yes,
Sir,
We don't
because
have
we have
time.
got to find acceleration. In fact, we can use v. We can't use anything related with t. The first two equations of motion have t in them, and we don't know t. So let's do this now. V is equal to 0. Again, it's 0 square minus
50
50 square is
so
equal to
into
2 into a into s 0.08. Don't make this minus, folks. A yourself, it will come, the value will come to be negative. Don't put a minus a here. So this becomes how much? 0 minus
50.
2500 is equal to, sorry? No, yeah, minus. My into 2 into a into 0.08. Therefore, a comes to what, folks? Minus 2500 by 2 into 0.08. So this comes to 1250 by 0.08. 1250 by 0.08 is what? 125000 by 8. Can I write it this way?
Yes, sir.
So acceleration, it 8 ones are 845, which are 40, 40, 58, 6 are 48, 20, 16. I might be wrong, folks. Just calculate. Meter per second square, and this is minus. So this is the acceleration. It's a huge, but it's huge. Just look, a bullet travels with terrific speed, right? And it hits the wall and stops in 8 seconds. There must be a terrific retardation. You can check the.
It's fired with 50 meters per second. How can it stop with?
It is fired with 50 meters per second and it hits a wall. It still goes 8 centimeter. It's half the small scale that it has gone. How much do you think it should go? Where is time here?
No, so exactly. If it's fired with 50 meters per second,
Yes.
it's getting stopped with an acceleration which is more than the velocity, initial velocity.
This is negative velocity, terrific acceleration. You can check negative, right? You can check and find out. Let us not argue on the logic here. Let us not argue on the calculation here. Let's argue in the logic if you have any. What is your question? Just substitute this value in v is equal to in this, and you see now that you know acceleration and you already know that the body is coming to rest. Just reverse calculation karo. See if u comes to 50 or not. You can see for yourself. Are you folks good with this? So the good news is that we are doing the last question in this iteration. Question number 20 is what we are doing now. And from here on, we will go on to question number 13 and others. So I think this is a very halwa question. You know what halwa question is? Very easy question. So this is time, which is in seconds. I've not erased this. I'll check once, folks. This is coming out to be a weird number, but that's fine. Logic's fine. We'll see the calculation. But for now, let's focus on this. Velocity, it's given in meters per second. Very easy question. The velocity time graph shows the motion of a cyclist. Find its acceleration, folks. So this is at 20. This is 20 meters per second. And this is 5, 10, 15, 20, whatever. 5, 10, 15, 20, 25. And this is the time axis. Now the questions are, 1. What is its acceleration, folks?
Sir, I can't see your screen.
0.
Sir, no
Who can't see my
acceleration.
screen? And is there anybody else who can see my screen?
0 meters per second.
Is there anybody else who can see my screen? पहले मेरा आंसर का जवाब दो ना यार क्वेश्चन का. Can you people see my screen, all of you? Others?
Yes, sir, we can see.
Okay, so others can see. So if somebody can't see, it's his problem. Fix it. Now come to this board. Yes, Sankalp and Tejashwini, I think there was somebody else who gave the right answer. Whenever the question is acceleration, don't get confused, folks. Don't get confused. I'll tell you how to ascertain whether there is acceleration or not. Acceleration means change in velocity by time. In this graph, do you see any change in velocity? No, man, the velocity is 20 all the time. The velocity is not changing, so its acceleration is equal to 0. Don't worry about any formula. That's why I say don't rely on formula. The formula can make your lives miserable most times. No formula involved. Constant acceleration. Yes, all of you. What is the second bit? Its velocity. The velocity time graph shows the velocity. So what is its velocity? Man, how can you get such easy questions? Its velocity. There is no second answer, right? It's only 20
20
uniform
meter
motion,
per
20
second.
meters per second. And the third one, yes. And then the third one, the distance.
Sir, we should use the area of square formula, I think so.
Yes, very good. The distance covered in 15 seconds, right? So in this case, because it's a velocity time graph, draw one perpendicular like this and calculate the area of this shaded area. That's the calculation. So this much is how much, folks?
15.
This is 15 and this is 20, right?
Yes.
So the distance time graph, the distance covered is equal to 15 into 20, and that comes to 300 what? Meter, kilometer, light year, what? Meters.
Meter per second. Meters.
Brilliant. That's how we solve this question. So you would have seen that I was explaining, so it took us some time. But otherwise, do you see that all of these three can be literally answered in 10, 10, 10, 30 seconds? And even the 30 seconds that you take is because we are having to write some things down. Otherwise, it's actually a 1 second question, right? If you have understood the graph. Wonderful, folks. You people have done a good job. I think we are not done. We are done with only the even questions, starting 6. So next question, I'm solving 13 because somebody asked for 13 in between. Once we're done with 13, I'll go to 7, 9, 11. I'll see how many we can solve until 10:45. Yes, all of you. Copy this down, folks. I'm taking a 30-second break. How many of you are following, folks? No one. Why am I taking this class? Kya was, uncle? Tejashwini, not following. Aditya,
Following.
Following, sir.
Saket, I'm just
Following, sir.
asking who I have seen. So I think
Like
these guys
following, sir.
they're attending. I don't following. All right, Rudraksh hai, Shreyas hai. Rudraksh hai, Shreyas hai. Okay, folks, I hope you people are following. Good. Just ask me questions whenever you don't follow. Great, man. Great. And who all get 100% in physics? Do text me. I will know my students. I know. I am in touch with them. But others who are not in my tuition, just let me know, folks, who all who all scored 100% in physics. I have gifts for them, so don't miss out. Don't miss out. You will miss out on a gift if you have missed out texting me after scoring 100%. Question number 13. Get this right, folks. Bring your attention. Don't be in a hurry. Don't be in a hurry. Yeah, don't be in a hurry to copy. I will give you time. Get this right. Question number 30 is a conceptual question. Every question is conceptual for that matter. But here it's conceptual and you'll have to organize things a little. Question number 13 is what we are talking about. Get this right, folks. The driver of a train traveling at a speed of 72 kilometers applies brakes and whatever. So you can straight away see that this train has an initial velocity of 72 kilometers per hour. There are two
Yes,
trains
sir.
actually that we are talking about, so I'll start it here. So there are two trains, okay? We are talking about train A and train B. Let's do both of these side by side and it becomes very easy. Train A and train B. So a train A is traveling at, so here U, how much is this, folks? 72 kilometer per hour. So can you convert this to meter per second?
4 meter per second.
20.
20 meters 20 meters per second, yes. And it
V is
retards at
0.
train uniformly. The train stops in 5 stops, folks. V is equal to 0 and the time that it takes is 5 seconds. Wonderful. Another train is traveling on the parallel track, not on the same track. Important. Yes, it is on the parallel track with a speed of 36 kilometer per hour. So you all agree that U here will be 36 kilometer per hour. Straight away convert it. It doesn't matter you need it or not, but it's worth spending 5 seconds, folks, 10 seconds, whatever. Meters per second. So this comes to how much? 10 meters per second. You all agree that this is 10 meters per second, all of you? And then this train also stops, which means again v over here 2 is 0 and the time this guy takes is 10 seconds. So are we good with compiling or organizing all the data that we have in the question? This is very
Yes.
important. Yes,
Yes, sir.
whatever is given in English and we have just presented the data to ourselves and eventually to the teacher, so that we are able to make complete sense out of this in little time. Plot the time graph for both the trains. Plot the speed time graph for both the trains. What will be the speed time graph now?
Sir, I have one doubt.
Time,
Sir,
seconds.
sir,
Yes, tell me. Tell
why
me the
time
speed.
is always represented on x-axis?
Because it is an independent quantity.
Good question. Why is time always why is time always represented on the x-axis? It's not only about time. Whenever you have two variables, so a two-dimensional graph will represent two dimensions, right? One on the x-axis, and one on the y-axis. Now, out of these two, one is the independent variable. Which one comes first? Does time drive motion or does motion drive time? It's time, right? In 1 second, we have this much. In 2 seconds, we have covered this meters. In 3 seconds, we have covered this much. So it's the time that is the fundamental unit when it comes to all of these quantities or these pairs. The independent with time first and then motion. So the one which is independent is represented along the x-axis. Okay, this much for now. We can talk about this later in some other class in greater detail, but I hope it answered your question. Now, what is the,
Sir,
so here we are
sir,
talking about 20 meters per second as the initial
I have a
velocity,
doubt.
and yes,
Sir,
tell me.
sir, in train B,
Tell me.
initial velocity is 36 and 5 by 18 is there, right, sir? We
Hmm.
can cancel 36 and 18, right, sir? Ones and twos.
That's what I have done, no? 18 into 2, that's why 2 into 5 is 10, no? You want me to cancel? Okay, I'll do that.
Sir, direct means it will be confused, sir.
That's how I got 10, no? That's how I got 20. Okay, no, that's what I meant actually. But yeah, if you are confused, then okay, I've got answered. I hope this is clear. So look, what is the maximum? When you are drawing the x and y axis, we must look at the data and see what is the maximum on the velocity graph that we have got to. So this is the speed time graph. This is the speed. So speed will be along this. Let's put this in meters per second. Just make sure that you write the units and time is in seconds. So do you see here that the maximum that we need on the time on the motion axis is on the speed axis is 20. So let us take 5, 10, 15, 20. This is the maximum that we need. So 20 is what we have taken. And the time is all about 5 seconds. So 1, 2, 3, 4, 5. Hey, making sense, all of you? So let us now plot this.
On the same graph.
Is it on the same graph?
Sir, it's said to plan
Question number
both on the
13.
same graph, sir.
Plot speed time graph about the same paper. Okay. So we'll do both together. So in this case, what is it? Okay, and yeah, 10. So 10, I think, will be a little more. So let's do this 2, 4, 6, 8. How many times will I erase this? 10. We are good. I think I should have drawn a bigger graph, but that's fine. So now let us plot these points, folks. The first one is we are doing for train A. So here it starts from 20 meters per second and it comes to 0 in 5 seconds. So mark the 5 here. Don't you think this graph will look something like this, everyone?
Yes, sir.
This is for train A. Makes sense? And here it started from 10 and came to 0 in 10 seconds. This train is slow and it's taking more time to stop. Okay, so this is, don't draw graphs like I'm drawing, make it clean. I've also tried to make it clean, but it's got a little messy. Absolutely clear, folks. Absolutely clear how these graphs represent the motions of trains A and B respectively.
Yes, sir.
Wonderful. So it's a nice question. You don't have any formula to use, but you have to represent. See, these things will not come with formulas, folks. This will come only if we understand the concept. So this is question number 13. Because we have 8 minutes and will not be able to solve all questions, folks, I now will let you people tell me which question you want me to solve from the remaining questions. So we have
Sir,
7,
in this question,
9,
they also asked
11.
us to
Sorry.
calculate the distance.
Traveled by each train after the brakes are applied.
Calculate the distance, is it? To calculate the distance. So
Yes,
if you are to calculate the distance, very easy, right? So in the first case for train A, this is the area that we are interested in. For train A, it will be half into base is 5 into 20. Hey, making sense? So it is 20 meters. And for train B, what is the area, folks? I'm erasing this so that I will I will highlight the train B. So we are talking about this area. Yes, all of you. So for train B, in a speed time or in a velocity time graph, the shaded area, the area under the graph that this graph makes with the x-axis gives us the distance, no? So in this case, will it not be half into, what is the base? It's 10. And 10 again. So this is 50 meters. And it makes sense. This is coming to a stop in just 5 seconds. So obviously it would have covered less distance, and it's also about the speed, but this is how we will calculate the. Hey, so Vasu, Harshit, are you people? I just realized you are also here in the class. I don't know, Rohit, I don't know
Sir,
who else is
the
here, who
first
else is
answer
not.
is
So I may not
50,
call
no?
everybody's name, folks, but I hope you are following.
Sir, for
Yes, sir.
train it should
2
be
into 10,
50.
50 hoga, yeah, right,
Yes,
right,
sir.
right, right. So this is, yeah, right. So it's 2 into 10 here, right? So this will be 5 into 10. Thanks, uncle, for correcting. Yeah, this is 50 meters. Hey, both of them are interesting. Both trains are actually, covering equal distance from the time the brakes were applied to the time it stopped. Convinced? Okay. So, folks, 6 minutes, 7 minutes now. Any question that you have across the remaining exercise, the sheet that we have not
Sir,
solved?
90.
Anything? I think we'll be
Sir,
able to
90.
take 2 questions.
Sir,
Question
19
number
and
19.
11, sir.
Okay, so we'll solve number 19. 19 will solve. And let me hear from
Sir,
somebody
the
else so
ninth
that it
question.
gets distributed. So I'll take question number 19 for you. And if there
That is
is
also 11, sir.
ninth, okay. So I'll
Sir,
solve
ninth
number
question.
19 and ninth. Okay, others 11th also will solve. Okay, ninth. So let's do number 19 first. Okay. So attention, folks. 19. A train travels at a speed of 60 kilometer per hour for 0.2. So it is about adding all. A train travels at a speed of, so let's take speed 1 is equal to how much? 60 kilometer per hour. And time is equal to 0.52 hours. Yes. Speed 2 is 30 kilometer per hour. 30 kilometer per hour. And time 2 will be, it's given 0.24 hours. The third part of the journey, 70 kilometer per hour. And time 3 is how much? For 0.7 hour. What is the average speed of the train? So what do we have to do, folks? Average speed is what? So average speed, we know average speed is equal to
Total distance by
total
total time.
distance by
We should add all the
time,
distances by
all
add all the
units.
times.
What is the distance? Yes, so here D1 will be S1 into T1. I'm not solving this question, folks. I'm just telling you how we solve. D2 is S2 into T2. And T3 is equal to S3 into T3. Yes, so this will be S1 T1 plus S2 T2 plus S3 T3. You all agree? And the total time is T1 plus T2 plus T3. Solve this class 6 algebra and you will be able to get it. Number 9. I'm solving question number 9 next. A ball is thrown up vertically, rises to a height 12 meters. Get this right, folks. Question number 9. You can copy together or take a screenshot later. Don't worry about copying. You will miss it otherwise. A ball thrown up vertically rises to a height of 12 meters. So height in this case, is this not the distance? Is this not the distance, folks? Distance. I'll write distance. This is confusing sometimes. Distance is denoted by the letter S. Distance S is equal to 12 meters. And the ball is thrown up. When it is thrown up, folks, what happens? To a height of, calculate the velocity with which the ball is thrown upwards. So initial velocity is what we have got to find out. The ball is thrown vertically upwards and it is reaching the highest point, which means the initial velocity is 0. Are you good with this, folks? If we are throwing the ball, after it reaches the maximum height, why does the ball stop there or it comes back? Because the velocity has become 0 at this point. So the velocity with which we throw is the
Gravity.
initial velocity, and the final velocity in this case is when?
Excuse me, sir.
What gravity, folks? Yeah, we'll come to gravity as well. G.
Sir?
Yes. Yes, Nathan is here. Okay.
Sir, not
Yes,
Nathan.
Nathan. Yes.
Sir, I'm Taksh.
Oh, it's not Nathan. Yeah, go ahead. Go ahead.
Sir,
Yes,
here
Taksh, go ahead.
the graph which you had told for this, does it include the motion of like the velocity of going up and coming down both? Like for question number 10, you had told a graph.
Mm-hmm.
Sir, like same question,
Yeah, I
does it?
told you, right, that, in for question number 10, when I was explaining. No, why are we looking at graphs here? We are looking at, if we are to represent this motion in a graph, that is another part altogether, right? Let us first solve the question that this thing is all about. Question number 9 doesn't talk about graphs, right? A ball thrown vertically rises to a height of 12 meters, so distance is 12. Initial velocity is what we have got to find out. Final velocity is where the ball has reached the highest point, its velocity becomes 0. That's why it starts falling down. And it is against gravity. You all know that gravity is down and the ball has been thrown up. So will it not be minus 10 meter per second square? Yes. So now what are we required to find? We already know that we have got to find. There is no mention of time anywhere. So it becomes obvious that the equation that we will use is, yes, all of you, v square minus u square is equal to 2as. So what is v? 0. What is u? We have got to find out. What is a? Minus 10. And what is distance? 12. That gets us what? Minus u square. Don't miss out on the minus, folks. You'll get the answer wrong otherwise. Is equal to 2 into minus 2 into 10 into 12 comes to how much? This is minus and minus gone. That implies u square is equal to 2240. Is that right? 240. So 240 is equal to how much now? That implies u is equal to, so it's 2 into, I'll just write this down. This is square root of 2 into 122 into 62 into 32 into 2 into 120 into 3 into 5. Eventually it comes to 4 root 15 meters per second. This is the velocity with which the ball was thrown upward. Get this right, folks. Now remove the physics hat and try to understand what this question was asking us. This is the velocity with which the ball touched. In case I did not answer a question, reach me after the class. I will explain to you. You can call me directly. Anyone for that matter. You can text me. You can call me today if you have any questions. And any other questions in this sheet or anything in science in your upcoming exam that you have doubts in, I'll try to help you. But for now, let us focus on this. I think we have already reached the time. So we'll wind up now, folks. Question number 11, somebody had a doubt. You can text me. I will solve that question and send it to you. We want to stop. We want to start on time and we want to stop on time. And you also have got other things to study. So are we good with this part? Is there anything else in this question number? Yeah, the time taken by the ball to reach the highest point. So this one is easy now. We know v is equal to u plus 80. You can apply this because you know everything except time. So what is v? We know is 0. U, we just found out 4 root 15. Plus a becomes, this is minus 10 because it's plus into minus, minus 10 into t. Find t. That implies what, folks? 10t is equal to 4
Sir,
root
what is
15.
that G in the
Therefore,
bracket,
T
sir?
is equal to 4 root 5 by 10. 1 second. That's the
Sir,
answer. What is it in bracket? Where is the bracket?
Sir, in that
Minus
ninth
10.
question, second bit.
Where is the bracket?
Sir, it's like G is equal to 10 meter per
I don't see
second.
any bracket here. Yeah, G is equal to 10. The acceleration due to gravity is 10 meter per second square. No, acceleration due to gravity, you know, right? It is usually the exact value is 9.81 something, but they are rounding it to 10 so that our calculations are easy. That's what we are using here, no? In this is 10. Even here we have used minus 10. This is what you're using. All right, folks, have a wonderful rest of the day. Prepare well. Ask me any questions that you have doubts in and do your exam very well. And all of you, send me whoever scores 100% in physics. Let me know. I have a gift for you. That's all, folks. Bye-bye all now.
Bye, sir.